So in this video, we're going to cover the last part of exercise 8.8. Here we want to prove this, and the proof has already started, but we need some kind of justification for these lines. Now, the first line seems to be some kind of an axiom or something that may have been derived. I did it a bit long, so I'm going to do this a bit separately. So we'll just show that this is provable in propositional logic. This can just be read as C implies B, where C is for all x B and B is B. So C is just for all x B, and A and B are the same thing. So we need to show that this rule here is admissible. Whoops. There we go. So there are a lot of implications here. So I'm going to start with axiom A0 and have a bunch of assumptions. So on line 1, I'll have B implies A, C implies B, and then I'll have my C implies B from A0. So I can have this because I've assumed C implies B. Now I'm going to do the same for B implies A. So I'm going to have B implies A, C implies B, and then B implies A by A0. If we now look at lemma 413, lemma 413 says that if you have C implies B and B implies A, then you have C implies A. So we'll use lemma 413 to get that. Lemma of C implies A. That was 413.1, and we're going to apply it to line 1 and line 2. And now we just need to use deduction theorem. So remember, we want to have a C implies B implies A, and C implies A. So we have C implies A, now we just need to move the other two over in the correct order so that we can get to where we want to be. So we first want to move the B implies A over. So then we'll have C implies B, and then we have B implies A implies C, implies C implies A. That was deduction theorem on line 3. And then we'll use deduction theorem again on line 4 to move over the last implication. So C implies B implies implies A. There we go. So this is how we have shown the first line through using A0, lemma 413, and deduction theorem. So just imagine that C is this for all x B. So remember that. Now I'm not going to include this proof as part of the rest one, just to make it a bit more clear. So we'll just use PL as a justification. So I'll take away that. So using PL as justification, and you saw before how we showed this. Now this is just lemma 8.24. We can have a look at that again. 8.24 lemma, it says that for all x A implies A. So here A is just B, so we can use that. So that's 8.241. So now it's pretty obvious that we're going to use modus ponens to get this here. So we'll just use that, modus ponens, and that gives us B implies A implies for all x B. B implies A, and that was modus ponens on line 1 and line 2. So now we almost have what we need. We just need to introduce this existX symbol right here. And just pause here for a minute if you want to figure that last line out yourself. So if we go and have a look at the rules that we have, of course, again, the introduction of the existence symbol here, which we can do if we have A implies B and X is not a free variable in B. B here, again, is for all X, B implies A, and this is the same as last time. The X is not a free variable in B because it's covered by the quantifier, and X is not a free variable in A because the exercise tells us that X has no free occurrences in A. So we are allowed to use this rule. So then by EI on line 3, we can use this, where let's write that X has no free occurrences in for all X, B implies A. Perfect. So the final line, you have existence X, B implies A, implies for all X, B implies A. Okay, so that was it for the last part of exercise 8.8.